Building your own PC. A step-by-step guide. Building your own PC is an immensely rewarding project that not only deepens your understanding of how computers work but also gives you the satisfaction of customizing a machine to perfectly meet your individual needs. The process begins with careful planning and research, where you need to determine what the primary purpose of your new computer will be. Whether you plan to use it for gaming, video editing, programming, or everyday tasks, your intended use will guide the selection of components such as the processor, graphics card, memory, and storage. Establishing a budget at this early stage is crucial as it helps determine the performance level you can realistically aim for while balancing cost with future-proofing considerations. As you deliberate on these aspects, it is vital to compare component specifications and read reviews to ensure reliability and compatibility among the various parts you intend to purchase. Once you have a clear understanding of your performance requirements and an established budget, the next phase involves selecting your components. The Central Processing Unit, CPU, should be chosen based on both the performance needs and the ecosystem you want to enter. Some CPUs come with integrated graphics that are sufficient for everyday tasks, while others require a dedicated graphics card to handle more demanding applications. Simultaneously, the motherboard is the heart of your build since it dictates which components can be used together. It is important to choose a motherboard that matches your CPU's socket type and offers sufficient expansion slots, ports, and features that support your system's future upgrades. In addition to the motherboard, selecting memory, RAM, involves identifying the amount and speed that will best suit your applications. Modern systems typically require a minimum of 8 to 16 gigabytes for smooth multitasking, though gamers and professionals may opt for even more. Similarly, considerations for storage include deciding between a solid-state drive, SSD, for speed and responsiveness or a larger hard disk drive, HDD, for capacity, with many modern builds opting for a combination of the two. Equally important is the power supply unit, PSU, which must provide enough power with some headroom for future upgrades. Research for a unit that is certified for energy efficiency and has the appropriate wattage for your chosen components. Other essential elements include the computer case, which not only houses these components but also supports proper airflow and cable management, and any cooling solutions required, such as additional case fans or liquid cooling systems, especially if you're planning on overclocking your CPU or GPU. After the selection and procurement of parts, gathering the necessary tools and preparing your workspace is vital for a smooth building experience. Ensure that you have a large, clean, flat surface free of static electricity, and consider using an anti-static wrist strap to protect sensitive components from electrostatic discharge. Take some time to read through the manuals for your motherboard, case, and other components since they often provide useful instructions specific to your build. Organize all your screwdrivers, cable ties, and any other small tools you might need so that you can work methodically without interruption, and plan your assembly process in your mind before physically beginning. The assembly process starts with the preparation of the motherboard. You will first install the CPU into its designated socket on the motherboard by aligning the gold contact or the notches on the CPU with those on the socket and gently pressing it back into place, ensuring that it sits evenly without applying too much pressure. Once the CPU is installed, carefully apply a small, pea-sized dot of thermal paste on the processor's surface if it does not already come pre-applied on the cooler. This paste is crucial for ensuring a firm thermal connection between the CPU and the cooler, facilitating effective heat dissipation. With the paste applied, mount the CPU cooler according to the manufacturer's instructions, making sure that it is securely fastened so that it remains in constant contact with the processor. At this stage, installing the RAM into the appropriate slots on a motherboard is the next task. Be sure to open the retention clips on the slots, align the notch on the memory stick with the key in the slot, and firmly press down until they click into place, ensuring that they are seated properly. Before moving to the next phase, it is advisable to test the motherboard outside the case in what is known as a breadboarding setup. This process involves connecting only the essential components, the CPU with its cooler, one stick of RAM, and the power supply, along with a minimal display connection, so that you can power on the motherboard and verify that it posts Power on Self-Test successfully. A successful post gives you the confidence that the core components are functioning correctly before you proceed with the complete build. Once the motherboard and core components are verified to work individually, begin installing them into the computer case. First, install the I/O shield that accompanies your motherboard into the designated slot on the back of the case, ensuring that the ports will align correctly. Next, place the motherboard into the case while aligning it with the standoffs that have been pre-installed to prevent direct contact with the case, which could cause short circuits. Secure the motherboard with screws provided by the case manufacturer, taking care not to over-tighten them, which could damage the board. With the motherboard installed, position the power supply unit into its designated area in the case, typically at the bottom or top, and securely attach it with screws. Route the primary cables, such as the 24-pin ATX power connector and the CPU power connector, so that they reach the motherboard without causing cable clutter. It is essential to plan cable paths early in this process, as good cable management not only provides a neat appearance but also improves airflow and cooling efficiency within the case. The next step is to install additional components. If you are using a dedicated graphics card, insert it into the correct PCI Express slot on the motherboard, ensuring that it clicks firmly into place and that its external ports line up with the slots at the back of the case. Secure the graphics card to the case using screws to prevent any movement, which could lead to disconnections during use. For storage devices such as SSDs or HDDs, mount them in the appropriate drive bays and connect the necessary data cables, typically SATA cables, and power cables from the PSU. Solid-state drives might also be mounted in specialized brackets or on dedicated mounting points, as required by your case's design. If you have additional expansion cards or peripherals such as Wi-Fi modules or sound cards, install them in the appropriate slots and secure them as necessary. With the primary hardware installed, proceed to manage the wiring and cables throughout the case carefully. Proper cable management involves routing cables through designated channels and using cable ties or Velcro straps to bundle them neatly away from airflow paths. This careful planning enhances the overall internal aesthetics and, more importantly, ensures that the cooling systems operate effectively by allowing air to circulate unobstructed. Attention to cable management at this stage will prevent clutter and simplify any future upgrades or maintenance, as well as minimize the risk of cables interfering with fans or other moving parts. After all components have been installed and cables neatly arranged, it is time to connect the remaining peripheral devices to the motherboard. These include connecting the case's front panel connectors, such as power buttons, USB ports, and audio jacks, to the corresponding headers on the motherboard according to the manual's descriptions. Ensuring that these connections are made correctly is essential for the proper functioning of the case controls and external interfaces. Once these connections are in place, double-check every cable, screw, and connection point to verify that nothing is loose and that all components are securely installed. At this point in the build, prepare to power on the system for the first time. Connect your monitor, keyboard, and mouse, and then plug the power cable into the PSU. Press the power button and observe whether the system successfully passes the post and displays the manufacturer's logo or BIOS screen. If the system fails to boot, troubleshooting may involve checking connections, ensuring that the power supply is working correctly, or making sure that all components are compatible and seated properly. Patience and methodical troubleshooting are vital during this stage, as even a single misaligned cable or loose component can prevent a successful startup. After successfully booting the system, enter the BIOS or UEFI settings to ensure that all connected drives and hardware are recognized correctly. This step also allows for the configuration of boot priorities and the adjustment of fan speeds or other system settings based on personal preferences. Once satisfied with the configuration in the BIOS, proceed to install the operating system from a USB drive or DVD, following the on-screen instructions to partition drives and configure settings during the installation process. The installation of the operating system marks the final step in transitioning your hardware setup into a functional computer that is ready for software installation and everyday use. Throughout the process of building your own PC, attention to detail, patience, and adherence to safety precautions are paramount. Each connection, installation step, and configuration adjustment contributes to the overall stability and performance of your computer. By planning meticulously, selecting compatible components, and carefully assembling all parts, you can create a machine that not only meets your initial requirements but can also be upgraded and maintained as technology advances. The satisfaction of building your own PC lies not only in the final functional device but in the deep technical knowledge you assemble along the way, empowering you to troubleshoot issues, upgrade components, and fully appreciate the intricate interplay of hardware that underpins modern computing. Building your own PC is a powerful demonstration of how technology, when approached methodically and thoughtfully, can be tailored to serve your personal computing needs in a way that mass-produced systems often cannot, ultimately providing a foundation for both creativity and productivity that can evolve with you over time.